Hello everyone. In this question, we are asked to find the value of an infinite sum of r from 1 to infinity, and in the numerator it is the product of 4r plus 5 times 5 raised to the power minus r, and in the denominator it is the product of r times 5r plus 5. Okay, so it looks very clumsy. So let us see what we can do here. If we start with the sum, we are given the sum r goes from 1 to infinity 4r plus 5 times 5 raised to the power minus r upon r times 5r plus 5. Okay, so if we try to isolate this 5 raised to the power minus r, okay, let us try to isolate it and write it separately. So the numerator is now 4r plus 5 and denominator is r times 5r plus 5, and we are writing this as separately for the time being. Okay, so our target is to usually write these expressions in these sums as a partial fraction or using the method of difference. Okay, so if we see very carefully, in the denominator we are given two terms, right? We are given 5r plus 5 and r. Okay, and in the numerator this is 4r plus 5. So we can write the numerator 4r plus 5 as the difference between these two, like this, as 5r plus 5 minus r, right? We get 4r plus 5. Okay, so now let us see if we can do some partial fractions or not. R goes from 1 to infinity. Okay, so uh, on partially dividing these fractions, we now get 1 upon r times. Oh, sorry, I had made a slight mistake here. This will be plus r, right? It was minus r in the numerator. In the denominator, this will become plus r, 5 to the power r, right? So the first term now becomes 5r plus 5 will get cancelled out. So this is r times 5 to the power r minus 1 upon 5r plus 5 times 5 to the power r, as the sum goes from 1 to infinity. Okay, so I'll keep the first term as it is, and in the second term, if I take 5 common here, this becomes 5 times r plus 1 times 5 raised to the power r, and the sum goes from 1 to infinity. Okay, so now I can write this second term. See, this is the product of 5 and 5 raised to the power r. Okay, so if we try to apply the laws of indices, this will become r plus 1 times 5 raised to the power r plus 1, right? 5 times 5 to the power r is 5 raised to the power r plus 1. Okay, so now we see that this is a, you know, differences of two terms in the sum. Okay, so we can try to apply the method of difference here now, it seems. Okay, so on putting the value of r equal to 1 in the first term, okay, the first term is 1 times 5 to the power 1, so this is 1 upon 5. Okay, minus, this will become 1 plus 1 is 2 raised to the power 5 square. This is for r equal to 1. Similarly, for r equal to 2, this term will become 2 times 5 square minus 2 plus 1 will become 3 times 5 cube. Similarly, for r equal to 3, this will become 1 upon 3 times 5 cube, and we can see a pattern here. We see the second term in r equal to 1 is cancelling this term. Similarly, this term is cancelling this one. Okay, so this pattern will continue up to the last term. The last term is r equal to infinity. So if we put infinity in the denominator, we see that both these terms will become 0, right? And in the limiting values. So if we put infinity here, 1 upon infinity will become 0. And this last term also r plus 1, this infinity plus 1 is also 1 upon infinity. So this is also limiting value is 0. Okay. So we see that the only term that is left out is this first term. Okay. All the other terms will get cancelled here in this series. So the only term that is left out in this sum is this 1 upon 5, which is the required value of this infinite sum. Okay. So this is the final answer. And the key for this sum is just again this method of difference and doing this splitting of this fraction into differences of two expressions. Okay, so you can apply the method of difference. So this partial fraction is the key step. Otherwise, this is very solvable. Okay, so this is the final answer. Thank you.